Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. In the previous videos, we saw the intuition. Regression cleans both variables of x2 influence, then regresses what's left. Now, we make that precise. This is the Frisch Waugh Lovell theorem, and it is one of the most important results in econometrics. And in this video, we're going to see the intuition before we jump into another video where we see the algebraic derivation. So let's start from the full model. Assume we have a model that is y equal to beta 0 plus beta 1 x1 plus beta 2 x2 and an error term u. We want to estimate beta 1 in here, the effect of x1 on y, holding x2 constant. The standard approach would have been run the full regression and simply read off beta 1, and that works. But the Frisch Waugh Lovell theorem gives us a second way, and this second way is what is basically eye-opening. So keep in mind what we're going to use is the Frisch Waugh Lovell theorem. And shortly, I'm gonna refer to it as FWL from now on in the video. So what the FWL claims is that we can get the exact same beta 1 by following 3 steps, which unsurprisingly you've already seen in the intuition video. Okay? So when I say here exact same, it means not an approximation, okay? And keep in mind, it's not a shortcut that almost works. It's exactly the same number, okay? Students often don't believe it until they try it themselves. So keep in mind, I'm going to reiterate it again. We're going to get the exact same beta 1. And this 3-step procedure is the following. The first one is remove x2 from x1. And again, we've seen that we achieve that by regressing x1 on x2 and keeping the residuals, okay? So the residuals is the variation in x1 that x2 cannot explain. So get residuals that contain x1 not explained by x2, because whatever x2 is explaining, it's going to be in the beta of this regression of x1 on x2, okay? Step 2, we're going to remove x2 from y. Again, we're going to get the residual in here, which is the variation in y that x2 cannot explain. And step 3 is regress. So let me add here also get residuals so that you understand why I'm writing the third step as regress residuals on residuals. Okay? So the slope from this regression should be exactly beta 1. Okay? Now, it's not an approximation, it's not a trick. The slope from the regression of the residuals is numerically identical to the beta 1 that you get from the full multiple regression, okay? So every time you run a multiple regression, this is what the OLS is basically doing under the hood in the background where you can't see it, okay? The full regression and the 3-step procedure are mathematically equivalent. Now, what does the Frisch Waugh Lovell theorem generalizes, or what does it say? It says that for one controlled variable x2, okay, but it generalizes and says that it will hold for any number of controls. Okay, so that's the power of the theorem. So that holds for any number of controls. All right, so if you have a model where you have x1, x2, x3, let's say up to x5 or x6, all of them get partialed out simultaneously. So all of them get partialed out simultaneously. Okay, so this is why also multiple regression is so powerful. No matter how many controls you include, beta 1 always reflects the variation in x1 that is independent of all of them because they have been held constant. Okay, why this matters? This result, as I said, is the foundation for three of the most important ideas in econometrics, and these are omitted variable bias, because what happens when we fail to partial out a variable we should have? Okay, so what happens when we fail to partial out? It's foundation behind instrumental variables, okay? Because that is how we find variation in x1 independent of the endogenous part. Okay, and it's also very important for another methodology that we're going to see once we get into panel data methods, but it's important for fixed effects because you're partialing out unit level, okay? Which means that it's exactly the Frisch Waugh Lovell theorem applied to panel data. Okay, so everything we do from here builds on this theorem. The Frisch Waugh Lovell theorem also tells us something very practical. The coefficient beta 1 does not depend on which other variables are in the model. It depends on which variation in x1 remains after controlling for them. Okay, this is why adding a control variable can change beta 1 dramatically because it changes what variation in x1 is left over. If the new control absorbs a lot of the x1's variation, then beta 1 will change a lot. If it absorbs little, then beta 1 will barely move. Okay? The Frisch Waugh Lovell theorem proves that multiple regression isolates beta 1 by partialing out all the other variables, and keep in mind this is not approximate, it's exact. In the next video we'll prove this algebraically and see exactly why the three steps that we give here give also the same answer as the full regression. So stay tuned and I'll see you in the next video.